Okay, good day. My name is Philip, and welcome to chemistry class notes. Today, as usual, I'm going to be answering some Waec, chemistry past questions on periodic table, a little on bonding, isotopy, percentage composition, and radioactivity. All right. Without wasting much time, let's look at the first question. The electronic configuration of atoms of elements A, B, and C, and D are given as follows. This is 1s2, 2s2, 2p2, that's A. Then B, 1s2, 2s1. Then C, 1s2, 2s2, 2p1. Then D is 1s2 and 2s2. So the question here is arrange the elements in order of increasing atomic size given reasons. Question like this, the first thing you have to do, we have to know which element is A, B, C, and D. A, looking at the atomic number or the number of protons or the number of electrons here. When you count it, it's 1, 2, 3, 4, 5, 6. And in the periodic table, the element that has atomic number of 6 is carbon. So that's the first thing you have to do. We know that A is carbon. Then B is lithium. When you count 1, 2, 3, lithium. C should be boron. You count it. This is 1, 2, that's 5. Then D, the last one, that's 1, 2, 3, 4, and that is beryllium. Right? So we know that A is carbon, B is lithium, C is boron, and D is beryllium. But take note, in the periodic table, these elements, they actually arrange in a period. Because if you are counting the periodic table, when you reach hydrogen, you say hydrogen, helium, lithium. Lithium is in group 1, right? So after lithium, we have beryllium, then boron, then carbon. So you notice that these elements are in the same period, starting from lithium, beryllium, boron, carbon. And for atomic size, decreases going from period, but increases down the group. So you expect lithium to have the largest size compared to other elements. Why? Because lithium is in group 1, and on that period, the atomic number, decreases. So since lithium is B, so we have to write that first. So after lithium, we have beryllium. Beryllium is D. So we say lithium, then after that we have boron. Boron is C. Then the last one would be A. A is carbon. A. So it's B, D, C, A. Remember, B was lithium, D is beryllium, C is boron, and A is carbon. They are in the same period. And the reason would be as you move from left to right across the period, additional electrons enters the same shell. And when that happens, the attraction for the nucleus on the electrons increases, or you say the nucleus pulls the electrons inward, and by so doing, it reduces the atomic size. So that is the answer for that first question. So the second question, state which of the elements is divalent. When something is divalent, it has valency of 2. Group 1 element has valency of 1, group 2 element has valency of 2. So we're going to be looking at elements that is in group 2, because they said divalent, 2 valency of 2. So here we know that lithium is group 1. After lithium, we have beryllium. Beryllium is in group 2, and beryllium is D, right? So the answer would be D. Beryllium is divalent because it is in group 2 of the periodic table. So we have to say the answer is D, is divalent. It has 2 valence electron, right? It has valency of 2 or 2 valence electron. Beryllium, group 2 elements. Group 1 element has 1 valence electron, monovalent. So what this one is D. Beryllium is divalent. So the next one contains atoms with 2 unpaired electrons in the ground state. Contains atom with 2 electrons in the ground state. 2 electrons, unpaired electrons. Remember, I said unpaired electrons. Looking at the electronic configuration, you know that s orbital has, it's just one shell, and it contains a maximum of 2 electrons. So let's look at A. Remember we said A is carbon. So this is full, this is full. This is 2p2, right? Let's draw this p orbital. Remember, p orbital has 3 shells, and here 2. So if I put one here, I put the second here. So notice that there are 2 unpaired. Coming here, S, just one shell, there's only 1. That is 1 unpaired. Coming here now, P, just 1 unpaired. Coming here, it is full. So the answer has to be carbon, because it has 2 unpaired electron in this p shell. So the answer would be A. So this one said readily loses 1 electron from its atom during chemical bonding. The one that loses 1 electron from its atom during chemical bonding. Remember, remember group 1 elements. Group 1 elements, during bonding, they lose the atomos electron, just like group 2, they lose the atomos electron. So group 1 elements, in that question, group 1, we have lithium. Lithium is there. Group 2 is beryllium. So if lithium is to react, it has to lose its valence electron. It is only lithium that is a group 1 element in those examples given. So the answer has to be lithium. If it were to be group 2 element, they lose 2 electrons. So yeah, the answer has to be lithium, and lithium is B. Lithium, because it's in group 1, and group 1 they have one valence electron, and it is that valence electron that is lost during chemical bonding. That's why the answer is B, because it's in group 1. So the next question belongs to group 3 in the periodic table. Belongs to group 3, number 4 belongs to group 3 in the periodic table. So let's write from what we were given. Remember, we were given A was carbon, B was lithium, and C was boron. Then D was, beryllium. So we know that, carbon, boron. Boron is a group 3 element. Let's write the atomic electronic configuration of boron. So this boron, you can count it to get your answer. People that know it by heart. But after writing the atomic configuration, this first number here is the period. But for the group, since these two are the same energy level, so you add this and this to get the period. So 2 plus 1 is 3. That's why the answer to this question is C, which is boron. Boron is in group 3 of the periodic table. Another example of element in that group is aluminium. All right. This question, state one difference between electrovalent and covalent bonds. Because one of the major difference between electrovalent and covalent bonds is that for electrovalent bonds, it involves transfer of electrons, mainly from an atom, from a metal to a non-metal. That is electrovalent bond. Transfer of electrons from a metal to a non-metal. But for covalent bonds, they have to do with sharing. They have to do with sharing of electrons, mainly between non-metals. So that is one of the differences between an electrovalent bond and a covalent bond. So the next question, name 2 other bonds apart from the ones in B1 above, which binds atoms and molecules together. So apart from electrovalent bond and covalent bonds, we are asked to name 2 other bonds that bind atoms and molecules together. Of course, we know we have van der Waals attraction or van der Waals bond. We have hydrogen bond. We have metallic bond. We also have dative or coordinate bond. So those are other examples of bonds apart from electrovalent and covalent. So next question. State 2 characteristics of covalent compound. Why? Covalent compounds characteristics are maybe they have low melting and boiling point. They are soluble in organic solvents, and you can also say that they don't conduct electricity in solution because they don't contain ions. So these are properties. The other properties that you can also read up on. Remember, I said they have low melting and boiling point. They are soluble in organic solvents, and they don't conduct electricity in solution because they don't contain ions. So this question, what is isotopy. Isotopy is simply the existence of, two or more atoms of the same element. Remember, the same element having the same atomic number but different mass number. Then we are asked to illustrate with suitable examples. Okay, I can give, 2 or 3 examples. Okay, you can see these are examples of, um, isotopy. Remember, existence of 2 or more atoms of the same element having the same atomic number but different mass number. They are called, isotopes. So this last question, remember these questions are, 2005. Which of the following elements, calcium, fluorine, iodine, neon, magnesium, helium, are halogens, noble gas, alkaline earth metals? Remember, halogens are elements in group 7. There we have fluorine, chlorine, iodine, bromine. Noble gas, those people are, or you call them inert gases. They are in group 8 or group 0. There we have neon, argon, right? Helium, neon, argon, and others. Then alkaline earth metals. These are group 2 elements. There we have calcium, magnesium, beryllium, and the likes. So having that in mind, from here we know that halogens, that's to be fluorine and iodine. Then noble gases, of course, it has to be helium and neon. Then which one again? Alkaline earth metals, magnesium. So this is the end of the first question. Let's look at the second question. List 3 properties of elements which increase generally across a period in the periodic table. All right. The 3 properties of elements which increase across the period. We have electroaffinity, ionization energy, and electronegativity. Atomic size, decreases across the period. So like I said, the one that increases across the period, we have All right, then the next question. Give two differences between a chemical reaction and a nuclear reaction. All right, for chemical reactions, they are affected by external factors, e.g., temperature, you know, pressure, catalyst, right? But for nuclear reaction, they are not affected by those external factors. Then again, chemical reactions, they are not usually accompanied by great heat change compared to nuclear reactions. They are actually accompanied by great heat change. Then chemical reactions, the electrons are actually responsible for its reaction. Remember, the electrons, you know, are outside the nucleus. So it's those electrons outside the nucleus, or you call them valence electrons, they're responsible for chemical reactions. But for nuclear reaction, that actually takes place in the nucleus of an atom. While one is taking place in the nucleus, one is taking place outside the nucleus. So these are the differences between chemical reactions and nuclear reactions. So use the information provided in the table below to answer questions 1 to 7. So this is the table. We have elements P, Q, R, S, T, the mass numbers, atomic numbers. So which of the atoms in the table above are isotopes of the same element? Remember, isotopes, existence of two or more atoms of the same element having the same atomic number and different mass number. So from this table now, if you watch, it is only P and S. They have the same atomic number but different mass number. So this is isotopy, right? So P and S are isotopes of the same element. Then the next question. Which of the atoms contains 18 neutrons? 18 neutrons. Of course, to get the neutrons, you subtract the protons from the mass number. Proton plus neutron equals to mass number. So in order to get the neutron, you subtract the proton from the mass number. Remember, proton, same thing as atomic number. So from here, you have to subtract this from this. Of course, not this, not this, not this, not this. So 17 minus 35, you will get 18. So the answer has to be arrow. Why? Because to get the neutrons, you have to subtract the atomic number or the proton from the mass number as we are given on this table. So the answer is arrow. Is chemically unreactive. When we say chemically unreactive, those elements in group 8 or group 0, noble gases or inert gases, they are chemically unreactive. So which of them here is in that group? So we have to, okay, that should be this. That is T, 10. 10 is neon. 10 is neon in the periodic table. No. So 10 is neon. Neon is in group 8 or group 0. So they are chemically reactive. That's what they are called, noble gases or inert gases. So the answer would be T. So I'm going to put T. Then the next one readily forms an ion with 2 positive charge. Readily forms an ion with 2 positive charge. When I say 2 positive charge, they have valency of 2. So we're going to be looking out for elements in group 2 of the periodic table. So element in group 2, no, no, no. So 20 is calcium. Calcium is in group 2, and so calcium will only form ion with 2 positive charge. Remember, positive. If it were to be negative, then it will have to be oxygen. But they said 2 positive charge. That should be Q. Q is calcium. I'm going to put Q. Then this one forms ionic bond with arrow. Forms ionic bond with arrow. Forms ionic bond with arrow. So remember, arrow is chlorine, right? 17 is chlorine. Remember, so what will form an ionic bond with chlorine should be a metal. It should be a metal. And in these elements, this is, of course, this out of it. This is neon. This is oxygen. This is oxygen. So the metal here is calcium. Calcium would form an ionic bond with arrow. So the answer would be Q. Attains an octet structure by accepting 1 electrons. Attains an octet structure by accepting 1 electrons. Of course, from that table, remember, P was oxygen, Q was calcium, R was chlorine, S was oxygen, then T is neon. So which of them attains an octet structure by accepting 1 electron? Remember, the non-metals, they accept electron. Some might accept 1, some might accept 2. But in that table, you notice that chlorine, atomic number of 7, has 7 electrons in its atomos share. So in reacting, it needs 1 electron to attain that octet structure of noble gases. So the answer would be arrow, which is chlorine. Why? Because it accepts 1 electron during chemical reaction. So the answer would be arrow, chlorine, because it needs to fill its share. So it belongs to the S block in the periodic table. Belongs to the S block, in the periodic table. In this type of question, remember, S block elements are on the left-hand side, right? While P block are on the right-hand side. Then in the middle we have D block, transition metals. So from that table, that means group 1 and group 2, they are S block. And in that table, the only element in group 1 or 2 would be calcium. Calcium is in group 2 element, so it's an S block element. So the answer would be Q. This is the next question. State Pauli's exclusion principle holds true of maximum multiplicity. Then write the electron configuration of copper ions. So know that there are 3 rules for filling in electrons in an atom. We have Pauli's exclusion principle, Hund's rule of maximum multiplicity, and we also have half-bow rule. But we are given to state Pauli's and Hund's rule. So Pauli's exclusion principle is saying that orbitals can contain a maximum of 2 electrons, but they must be in opposite spin. The other ways of saying it, or you can say no two orbitals can have the same value for all the 4 quantum numbers. That is also acceptable. But you can also put it that orbitals can contain a maximum of 2 electrons, but they must have opposite spin. For example, notice that this is the same spin. So this is wrong. One has to be going up, one has to be facing down. So this is Pauli's exclusion principle. Orbitals can contain a maximum of 2 electrons, but they must have opposite spin. Then Hund's rule of maximum multiplicity. Hund's rule is saying that orbitals are fed singly before pairing. Orbitals are fed singly before pairing. For example, let's say we want to fill in 3 electrons in this p orbital. Remember, p orbital has 3 shares. We want to fill in 3 electrons in this orbital. So what we do is 1, 2, 3. 1, 2, 3. Not, remember, 1, go to the next share, put 1, go to the next share, put another 1. If there's another one again, start from the first one, second, third. Not 1, 2, 3. One, 2, 3. So you notice that this is wrong. This is correct. 1, 2, 3. Not 1, 2, 3. So Hund's rule is saying that orbitals are fed singly before pairing. So this is wrong. It's correct. There's also half-bow rule, though we are not asked that, but half-bow rule simply means the orbitals are fed in order of increasing energy level. That is from 1s, 2s, 2p, 3s, 3p, then 4s, 3d. Increasing energy level. Once 1s is fed, you enter 2s. Once 2s is fed, 3s, like that. That's what the last row, half-bar row, is talking about. Then write the electron configuration of each of the following ions in copper. So you are told to write the electron configuration of this copper plus and Cu plus and Cu2 plus. Copper is 29. When you say something is Cu plus, that means it has lost 1 electron, meaning you're going to write for 28. Why? Because it has lost 1. This means it has lost 2. Right? So writing for 27 here and we're writing for 28 here. So this is 10, 10. This 28. So write for this one. So this is 28. This is 29. Remember, this one we lost 2, this one we lost 1. But I'm very sure some of you might be confused. Why after 3 pieces I move on to 3D 10. It will also be after 3 pieces I will have 4s, right? 4s1, sorry, 4s2, then 3D 9. But the electrons in the 4s orbital is transferred to the d orbital because there was an empty shell, so that one enters the d orbital. That's why you don't see the 4s shell. The same thing here. That happens because this form is more stable than that form. That's why you have to be careful when writing the electronic configuration of some elements like copper and some other transition metals. So this is the electronic configuration of copper plus and Cu2 plus. So the next question, give the number of unpaired electrons in each of the ions in B1. Number of unpaired electrons in each of the ions. D orbital has 5 shells, 1, 2, 3, 4, 5. Each of them carries 2. That is 10. So this is feed. It has no unpaired electron, or it has 0 unpaired electrons. So this one will have 0 unpaired electron because the d orbital is full. So for this one, it has 0 unpaired. Then for this one, this is 9, meaning there's 1 unpaired. Remember, D has 5 shells. Each of them contains a maximum of 2. So you'll be left with the last one. The last one will contain just 1. So this one has 1 unpaired. So the answer here is 1. The unpaired here is 1. The unpaired here is 0. Let me explain this again. Remember, normally we are supposed to write this first one like 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 4s2, and then 3d8. Normally you want to write it like, I'm talking about this one now, you want to write it like this. I mean 4s2, then 3d8, right? That is 28. But I said this arrangement, since remember this is 3d8, there's still vacancy in the shell, and since there's vacancy, this closest shell 4s will move into to complete the shell here. That's why it's now like this. Don't write it like this, right? That's why the 4s moves and enters the D shell. That's why the 4s is not among. The same thing here. The 4s enters the D shell because um, this combination is more stable than this combination is more stable than this one. That's why this one is correct and this one is wrong. So take note. Then state the type of reaction represented by the following equation. Of course, that wasting much time. This is a redox reaction. Why? So this is a redox reaction. Redox reactions are reaction in which one species, you know, is oxidized and the other species is reduced in the same reaction. One part is oxidized, one part is reduced. So in this case, remember oxidation is loss of electron, reduction is gain of electron. In terms of um, um, in terms of oxidizing, in terms of oxidation number, oxidation is increase in oxidation number, while reduction is decrease in oxidation number. If you watch, the oxidation number of copper here is 1 and here is +2. So there's increase in oxidation number. So this is oxidation. Then coming here, this is +1, then here, this one is 0. So in a reaction where there's oxidation and reduction, we call it redox reaction. So this one, write the formula of one compound of Cu plus. You know copper has two valencies, 1 and 2. This Cu plus means, valency of 1. And the major example there, would be Cu. Let's do it like this. Cu1. Oxygen has a valency of 2. So this copper 1 oxide. So let's do the next one. CuCl. They both have a valency of 1. So when you do this, at the end you get CuCl. So we have copper 1 chloride, copper 1 oxide. So this formula of this is one of the compound of Cu plus. Either you say this one or this one. So name the type of radiation that will penetrate lead block, be stopped by tin paper. Of course, the one that would penetrate lead block would be, gamma radiation. Gamma radiation. Then be stopped by tin paper. That is alpha radiation. So let me also add that beta radiation, that one will be stopped by, aluminum foil, but it's not among the question. Just in case, just know the one that penetrates lead block is gamma radiation. The one that will be stopped by tin paper is alpha radiation. Then the one that will be stopped by aluminum foil is beta radiation. Give the charge on each of the radiation mentioned in C1 above. Okay. Gamma radiation has no charge, while alpha radiation has no positive charge. Beta radiation has negative charge. So gamma is no charge, alpha is positive charge, beta is negative charge. Then what term is used to describe each of the following nuclear processes? Combination of two lighter nuclei to form a heavy nucleus. Combination, that is nuclear fusion. Then splitting of a heavy nucleus into two or more lighter nucleus, that is nuclear fission. Fission is splitting, fusion joining. Then time required for 1/2 of the atom of a radioactive substance to decay. Of course, this is called half-life. Okay, let's look at this one. Arrange the following ions in order of increasing size. Give reasons for answers in each case. We have Li+, that is lithium ion, potassium ion, sodium ion, then oxygen, fluorine, nitrogen. Okay, let's look at the first one. Lithium, potassium, sodium. Notice that, of course, they have a charge of +1, right? And you know that all these elements, they are in group 1. In group 1 elements, lithium is on top, followed by sodium, then potassium. So we know that atomic size, increases down the group, right? But across the period, it decreases. So don't allow this positive charge confuse you. The atomic size increases going down the group, and on top of this group, we have lithium. Before we have sodium, then we have potassium, meaning the largest would be potassium, followed by sodium, then lithium. So I'm going to write it like this. In going down the group, new shares are added to a particular element. That's why the size increases. But across the period, the same number of electrons enters a share. By going down, new shares are added. So the reason why potassium is larger than the rest is because it's down the group, and in going down, new shares are added. So that's for this. Then for this, we have oxygen, fluorine, nitrogen. For this element, they are all in the same period. We have nitrogen before oxygen, before fluorine. In going across the period, size decreases, meaning The smallest one would be fluorine, before oxygen, before nitrogen. So I'll do it like this. And one other thing, 2 minus, minus, 3 minus. All these are isoelectrons. They are isoelectronic, meaning they have the same number of electrons. Nitrogen is atomic number of 7. Then when, remember, this 3 means it has received 3 electrons, meaning 10. Fluorine is atomic number of 9, meaning if you say minus, that received 1, 10. Oxygen has an atomic number of 8. Then 2 minus means it has received 2, 10. So all these are they have 10 equal electrons. So that is like a tie. So the other factor that will now determine their size has to be, the fact that going across the period, the same number electrons are added to the same shell, and when that happens, there is more, attraction for the nucleus on the electrons, which pulls it in. And the further you go right, the more it pulls it in, and the smaller the element becomes. So that's why we have nitrogen greater than sodium, nitrogen greater than oxygen, greater than fluorine. So this last question. Determine the percentage composition of phosphorus and oxygen in phosphorus 5 oxide. So we are looking for the percentage composition of oxygen and phosphorus in phosphorus 5 oxide. First of all, you have to know the formula. You have to write out the formula of phosphorus 5 oxide. So this is phosphorus 5 oxide, P2O5. And in order to calculate, you calculate the percentage for oxygen, then for phosphorus, or phosphorus and oxygen. So it's going to be like this. So basically, this is what I'm going to do. P2, remember, this 2 is very important. Don't say P over, no. Look at the equation, P2. If it was P05, then it would have been P over. But since there's 2 here, you have to put 2 because you're looking for percentage composition of phosphorus. So it's P2 over P25 times 100. Then, sorry, this is O5. This is O5. This O5 over P25 times 100. We know that P is 31, O is 16. So you substitute into this equation to get your answer. You put P here. P is 31. 31 times 2, right? Then 31 times 2 plus 16 times 5. Divide then multiply by 1000, you get for P. Then for oxygen, 16 times 5 over, then this the same thing you did here, 31 times 2 plus 60 times 5, you divide, multiply by 100 to get your answer. So this was 2008. So that's all for now. Remember, your exam is coming up, I think next week. So you still have to, study other past questions, on council. You must have learned a thing or two from this video. So if you feel you like the video or you enjoyed the video, you can leave a like and subscribe. Thank you.